Let's evaluate the definite integral from minus 2 to 2 of x plus 3 times the square root of 4 minus x squared. Substitution will not work here. If you try u equals to x squared or minus x squared or 4 minus x squared, it will not eliminate all the x's and you will not be able to express the resulting integral in terms of just one variable u. So instead we're going to break this integral up into two separate integrals, into the sum of integrals. First one will be the integral from minus 2 to 2 of x times the square root of 4 minus x squared, and the second integral will be the integral from minus 2 to 2 of 3 times the square root of 4 minus x squared. Let's concentrate first on this integral on the left. We're going to solve it by substitution by letting u equal to 4 minus x squared. Notice that when x equals minus 2, u will be 0, and also when x equals to 2, u will also be 0. And differentiating u with respect to x, we end up with minus 2x, and then solving for x dx, minus 1/2 times du will replace x dx. So the resulting integral looks like this. First of all, it's the integral from 0 to 0, square root of u, and x dx is minus 1/2 times du. Any integral from 0 to 0, or 1 to 1, or 2 to 2, or 3 to 3 is 0. So to see this, why this happens graphically, we're going to see the function, look at the function x times the square root of 4 minus x squared. Its domain, the domain of this function, is all values of x between minus 2 and 2, because if we put in 3 or minus 3 or minus 5, we end up with a negative inside the radical, which is undefined. So that's the domain, and we now graph this. So here is minus 2, 2, and let's put a 0 right here. Now what happens at these points, if we plug them into the function, they all are 0. For any x between 0 and 2, for example like 1, y would be 1 times the square root of 3. Clearly that's positive, and that's like that for any value of x between 0 and 2. So the graph looks something like that on the interval between 0 and 2. Similarly, when x is minus 1, or anything between minus 2 and 0, we end up with minus square root of 3. That's negative. So the graph is completely under the x-axis over the interval 0, minus 2 to 0. It is symmetric. These two cancel each other. That is, the integral from 0 to 2 is positive. The integral from minus 2 to 0 is identical and negative. Therefore, we end up with 0 as a total integral. And that leaves this integral minus 2 to 2 of the square root of 4 minus x squared. If you've seen earlier videos, you know that this integral at this point in calculus 2 cannot be done by substitution. Instead, once again, we look to see what this function is. We are integrating square root of 4 minus x squared. If I square both sides, it becomes y squared equals to 4 minus x squared, or x squared plus y squared equal to 4. We recognize this as a circle with center at the origin and radius 2. But if we trace our step backwards from here back to here and then back to here, we see that the function we are integrating is actually upper semicircle, centered at the origin with radius 2. And this is what it looks like. It runs from minus 2 to 2. So it's precisely the integral that we have. So our integral is 3 times the integral from minus 2 to 2 of square root of 4 minus x squared. It is equal to 3 times the area of the semicircle. Well, area of a semicircle, first of all, we have a half because we have a half a circle, and then pi r squared. Well, r equals to 2, so 2 squared is 4 times pi. It's 1/2 times 4 pi. That's 2 pi times 3. The final answer is 6 pi. So let's come back to the integral we started with. It was from minus 2 to 2, x plus 3 times the square root of 4 minus x squared. We could have done the entire integral by graphs without actually integrating anything, and come up with a final answer of 6 pi. For more videos, visit www.mathprepvideos.com.